All right, welcome back, YouTube. This is my next video on my video about making a computer out of transistors. This one's going to be about the flip-flops, where we're using the clock and um, counting with the clock. Kind of cool, so stay tuned. Okay, so here's what I'm building. Data flip-flop has the clock signal at the enable pin. So if you remember, here's the data latch. Here's the enable, has the two NAND gates. We had our little enable pin. We had to enable it to change the data, right? So now we're going to use the clock to do that. So I have the clock input here, and it's going through a NAND gate. So this is an edge trigger. So we're trying to get it. We're trying to just get the edge of that clock signal, not the whole clock signal. So anyhow, I put the clock in these two. Here, this was our enable. This is where I put the clock into. And so I did figure out I needed to add another buffer right here. Otherwise, it wasn't working. I was having trouble getting this working. I added another buffer here. So I had the AND gate here, added a buffer, made that the enable. This is my clock. Also, this shows 6 buffers here. There's actually 9. I had to use 9 to get this to work. And then also on the output of this, I had to invert the output again to get it to work, right? So 2 buffers basically on the output, a buffer between the clock or between the edge trigger circuit and the flip-flop, and then actually 9 inverters into this AND gate. And the reason we're doing this is with the clock, we have a clock input here. So when it goes to 1, through an inverter is going to go to 0, right? And so this is never going to turn on, right? But if we put it through enough of them, 9 of them, it will add just enough delay that this will still be 1 for a split second whenever this one goes 1, which will give this a real quick pulse on the output, which is what we want, just a quick pulse. Every time the clock cycles, we get a quick pulse. This buffers it, and so that allows the enable to enable just for a quick pulse every time the clock signal. So, and only on the positive. But the clock's going to go positive, negative, right? So only on that positive is this one still going to be positive for a split second and give a pulse. So it's just on the positive clock cycle, we're going to get a pulse. And then, so this is going to be enabled just for a split second that allows our data to be stored here. And then what I did was I tied this NOT output back to our data, tied our data into the NOT, so that when this gets a quick pulse, this one changes the data for every other pulse. And so that's what's happening here. And you can see this is what I built. Here's my clock. Also, I had a little bit of trouble with my clock because I needed these 2 extra buffers. So I had my clocks here, and it was cycling back and forth just fine. But as soon as I plugged it into these buffers, I don't know. See, if I had an oscilloscope, I could see what's going on here, but I don't have an oscilloscope. I will get one eventually. But for now, I can't really see what's going on. But when I would take this output, put it into these buffers, suddenly it wasn't making it through these buffers. So I added a buffer on each side of the clock, and then that started working. So that was one of the problems I have with my clock. Once I added the buffers, after the outputs, actually this buffer is really doing nothing, but once I added this buffer and then put it into all of these, it started working. So, and then this took nine buffers and then an AND gate, and then it still wasn't working right. It was working, but it was cycling for every cycle of the clock instead of every other. So I added, after this AND gate, I added this extra buffer. That's this buffer right here that I added after the AND gate. Put that to the input here, which is this red wire jumpers, these 2 inputs together. And then here's my NOT output fed back into this AND gate, which is right here. And then let's turn it on and see it work. Okay, so there's my clock working like it should. And here's my output, flashing just like it should. And so if I move out a little bit, you can see what's happening, the cool thing that's happening. So for every positive pulse, this changes state. It goes through these buffers, through all these buffers, and this AND gate changes state. And then that allows the flip-top to flip just for every pulse, just for every positive pulse of that signal. So, which is making this cycle half of what this one's doing. And so if you look at it, it's kind of what the cool thing it's doing is it's counting in binary. If you look at this one, this is like your ones column, and this would be your twos column. And so let's see. Ready? 1, 2, 3, 0. 1, 2, 3, 0. 1, 2, 3, 0. See, pretty cool. So it's automatically counting in binary. So that's pretty cool, right? All right, so let me get set up for the next one. Okay, so the next thing I built is this JK flip-flop. You can see it here. There's just the two NAND gates, two buffers, and two 3-input NAND gates that have one input tied together for the enable or clock J and K inputs. And the third comes from, the previous, or the NAND gate that's after it, feeds back. And then here's what I built. You can see here. And so the idea with this, here's just my clock going. The idea with this is that you can set and reset. If you notice there's like a slight delay because it's waiting for the next clock pulse before it sets. See? Resets, right? And the cool thing you can do with this is if you press both of them, it'll just toggle back and forth. And if you look at the clock, toggles back and forth for every other clock cycle. So it's basically like counting in binary as well, just like the previous, just like the data flip-flop did previously. So anyhow, that's the JK flip-flop. So let me get one more flip-flop built here, and then we'll wrap this video up. Okay, so what I've built is a master-slave JK flip-flop. I'm not totally sure what's useful about this yet. We're learning, but so there's like an on, or I would think I'd be like the data, and then here's the clock. Clock gets inverted, goes into, I guess this is like a master portion, and this is a slave portion. That's why it's called master slave JK flip-flop. But then I had to add 2 more buffers to get this to work for whatever reason. Not too sure. Someday I'm going to get an oscilloscope and I'm going to check that and see why that is. Anyhow, so this is what I built. You can see it here. This is that. And so I guess one of the things that's good about this is it doesn't need the edge trigger. Remember with the clock, I had to build this huge long buffer so that we can just get the edge of the clock for the last flip-flop. This one doesn't need it, but let's test it without the clock first. We got the power on, and let's see what happens. So this is our, I guess would be like our data, and nothing happens. This would be our clock. And see, I can change it. Now it doesn't change anymore unless it's, I guess, getting the edge of that clock pulse. So if I hold this down, I can change it back and forth. Once I let go, it does nothing. Okay, so let me get the clock hooked into it, and and we'll see what it does from there. Okay, it's kind of interesting. I got the clock. My clock tied into the circuit through right here, and it's going through the one that is also inverted here. See, it goes up to the inverter right here. And if you look at this, if you like pause it on my circuit here, you can see, you know, this side and this side are the same, except for there's this extra inverter right here, which is inverting the clock. Anyhow, yeah, so the clock goes into that one, and then this one's just going to be maybe like our enable on, would be like enable, I'm thinking. So if I press the enable with the clock going, it switches. All right, let me zoom out so you can see the clock. If I just hold it, it just goes back and forth just like the other one, and you can see it's like, let me see if I can count in binary with it. So we got off, 1, 2, 3, off. Yeah, it's quick. It's hard to keep up with. Yeah, it's basically counting in binary as well till I let go, as long as I have it enabled. All right, cool. So this will do it for the flip-flop video. Now we're going to decide where to go from here. I'm going to just show you here. See, I was trying to build my own 7-segment display out of just LEDs and transistors, but it wasn't working the way I thought it would work. So I might work on that a little bit more, or I think maybe for my next video, I'm going to make a bank of memory. I think that'd be kind of cool, right? So I got to figure out how to do that. So stay tuned for the next one. Thanks for watching. Have a good one.